First, the chef collects groceries, just like data engineers gather and clean data for machine learning. Next, the chef prepares the meal, similar to data scientists building and training models to perfection. Then, the delivery driver brings the food to your doorstep. This is like deploying a model to make predictions in real time. Finally, customers give feedback, which helps improve future meals, just as monitoring and retraining improve model performance. The MLOps lifecycle is the backbone of any successful machine learning project. It ensures seamless collaboration between teams, model reliability, and compliance with ethical and legal standards. Let's explore the 6 key stages of the MLOps lifecycle. First is data preparation. High-quality data is the foundation of every successful model. This step involves collecting, cleaning, and pre-processing data to ensure it's consistent and reliable. Missing values, outliers, and redundant features are addressed. Finally, the data is split into training, validation, and test sets to create a robust pipeline for development. Next, we train the model. This involves selecting the right algorithm or architecture, optimizing the model's parameters, and fine-tuning hyperparameters. The goal is to develop a model that not only fits the training data, but generalizes well to unseen data. Once trained, it's time to evaluate the model. Using validation data, we measure metrics like accuracy, precision, recall, or F1 score to gauge performance. This step also ensures the model isn't overfitting or underfitting, addressing any weaknesses before moving forward. Then comes deployment. The model is integrated into a production environment, such as an API or application. Deployment ensures the model is accessible, scalable, and responsive. It's tested thoroughly to confirm it behaves as expected in real-world scenarios. Now, let's talk about governance. This step ensures compliance with industry regulations, ethical standards, and security protocols. Documentation, version control, and auditing mechanisms are implemented to maintain transparency and accountability. Finally, monitoring keeps the model reliable over time. Real-time tracking detects performance degradation, data drift, or other anomalies. Alerts help teams act proactively, and regular retraining ensures the model adapts to new data and stays accurate. From facial recognition to hiring algorithms, machine learning models can unintentionally cause significant issues. In one case, a facial recognition system scraped images without consent, violating privacy laws and leading to hefty fines. Meanwhile, a hiring algorithm was found to favor certain demographics, leading to discrimination and legal action. Both incidents highlight the importance of proper governance, fairness monitoring, and continuous evaluation with MLOps to avoid such violations, ensure compliance, and protect both privacy and fairness in AI-driven decisions. MLOps maturity is a journey, starting from level 0, where everything is done manually. Data scientists build, train, and deploy models without automation. At level 1, DevOps practices are introduced, automating parts of the pipeline like model deployment and monitoring. Moving to level 2, the focus shifts to explainability, ensuring that models are interpretable and transparent. By level 3, comprehensive monitoring is in place, with models continuously tracked for performance and drift. Finally, at level 4, the pipeline is fully automated, enabling seamless model training, deployment, and monitoring, allowing teams to focus on innovation and scaling their ML solutions. There are 2 types of MLOps platforms: cloud-native and independent. Cloud-native platforms like AWS SageMaker, GCP Vertex AI, and Azure ML are tightly integrated with cloud services, offering scalable solutions and seamless deployment pipelines. They're great for teams looking for end-to-end solutions with minimal setup. On the other hand, independent platforms such as H2O.ai, Domino Data Lab, and Databricks operate across multiple environments, allowing more flexibility and customization for specific use cases. Independent platforms are ideal for teams who want more control over their infrastructure and want to work with different cloud providers or on-prem solutions. A global leader in financial software, specializing in products for tax, accounting, and personal finance, faced significant challenges in scaling machine learning operations to meet growing customer demands. The company needed a robust, scalable solution for data preparation, model development, deployment, and continuous monitoring. Data for machine learning models starts in multiple sources, including Amazon S3 for large datasets, Redshift for structured data, and APIs for real-time inputs. For dynamic, high-velocity data, Kinesis streams data in real time into the SageMaker pipeline, where it's automatically processed and prepared for model training. Once data is in the pipeline, data scientists move into SageMaker Studio, an integrated development environment where they can build, experiment, and tune models using frameworks like TensorFlow, PyTorch, and scikit-learn. Here, they also manage experiments, tracking hyperparameters and metrics to optimize model performance. For consistency across models, SageMaker Feature Store stores and organizes features, allowing teams to reuse them across different experiments. This minimizes redundant feature engineering and speeds up model creation. Once the model is ready, AWS Code Pipeline automates the deployment process, integrating model testing, validation, and production deployment to streamline the CI/CD pipeline. Finally, SageMaker Model Monitor ensures the deployed models maintain performance by continuously tracking accuracy and data drift. If issues arise, it triggers retraining, ensuring the model stays reliable and efficient. This approach integrates data engineering, model building, deployment, and monitoring using AWS services to create a robust MLOps pipeline that ensures continuous, efficient, and accurate machine learning workflows.